So in this video, we're going to be learning about domain and range. Domain and range just tells you what values of x and what values of y are showing up on a graph. Now, to learn this concept for the first time, it's easier to look just at number lines. So we're going to start with those, and then we're going to work our way up to full graphs. So we're looking at this number line, and I want to know what values are included in this number line. So we can see there's kind of like a red line that goes across where all my values are. So I know we're starting at 0. I have a dot there, that's included. I know I have 1 is included, 2 is included, 3 is included. But because this is a straight line, it actually tells me that everything in between is also included in this number line. And we just need a way of saying that, what values, because I can see -1 is not included. So I need to have a way of telling people what values are being included. I can even see that above 10 will not be included because that line does not continue. There's a solid dot as if it's stopping there. So my values in this number line are between and including 0 and +10. That's how I would kind of say it. This number line includes values between 0 and 10. Now, what's another way of writing that in math? We can use something called interval notation. So not only can we describe it in words, there's shorter ways of doing it. So to say I have all of the values between and including 0 and +10, what I would do is I would take a square bracket, put my starting point. So on a number line, we always look at what is the farthest value to the left, in this case 0. And then I'm going to put a comma. And then I have to look what is the farthest value included to the right, and I know it's +10. And I close my square brackets. And this tells me, again, we're just including all the values between and including 0 and +10 in our number line. Here's another example on a number line just with different numbers. So we have a number of values. This one's a little different. I always like to start on the left side first when I'm looking at a number line. We see we have 20 here, and there's kind of this dot, but it's an empty dot. It's hollow on the inside. What this is telling us is this actually doesn't include the number 20 as a value, so it's missing, but it includes everything above 20. So it's like we're almost at 20, but it's not included. Now I look to my right, we have a straight line, and it goes past 25, and there's this arrow for the red line. What that arrow means is it goes on forever in that direction. So not only 26, 27, 28, but also 1,000, 10,000, a million, +10 billion. It's going to go on forever. We say that it's going to go on for infinity. Now, how would I write this? Whenever you have this empty circle on a value, instead of writing a square bracket, you're actually going to write a curved bracket. So the square bracket means that starting point is included with a filled in dot. A curved bracket means that the starting point or the end point is missing that value. So I'm going to start with my value furthest to the left, 20. Again, it's not included, but that's what the curved bracket is telling me. It's not actually included. Put a comma, and I have to now write the value furthest to the right. But we said this goes on forever. So the way to show that is using the infinity symbol. It's almost like an 8 on its side. So it would go to infinity, and then we would actually just have a curved bracket because the values will not stop at a solid point. They just go on forever. So how I would say this is this number includes all values from 20 to infinity, but not including +20. So here we have another number line. This one's different because we do not have continuous data. So it doesn't, we don't have a section that kind of goes on in a straight line. We just have a bunch of dots. And this is what we call discrete data. They're only at set points. Now, how would I describe this? Well, you could kind of say, oh, I have dots at like -2, 0, 4, 8, and 10. But when we're talking about domain and range, we don't always care about each individual point. We just kind of care what range they fall into. So what is the lowest and what is the highest? So in this case, my lowest value is -2, far on the left side, and my highest value is +10. So what I would say is the values of this number line include values from -2 to +10. How would I write that? Well, these are filled in dots, so I'm using the square brackets. I'm starting with my lowest value, putting a comma, and then my greatest value. Again, when we don't have a sign in front of the number, we assume it's positive, so that's a +10. When we're talking about domain and range, we're talking about where the values fall in. What section of a number line do the values fall into? And we explain that by giving the lowest value and the highest value. Now that was with number lines. We're going to move on to doing the same concept but on actual graphs. Now the only difference here really is instead of having a single number line, a graph is almost like having two number lines. So we have the x-axis, which is like a number line, and then we have a y-axis, which is also like a number line, just flipped kind of sideways. Now, because we have two different number lines, we also have two different names. When we're talking about the x-axis and we want to know what sections the values fall into, we call this domain. When we want to know what y values the graph falls into, we call that range. So we're doing the same concept. The words just tell us, are we dealing with the x values or are we dealing with the y values? So we are going to start with the x values. So we are going to do the domain. So what we have to do is we have to look at just the x values first. So what I'm going to do is I'm going to see what's my lowest x value on this graph, or what's the value that's furthest to the left. So I can see that this graph goes way out here, and I just want to know what value is that. Well, I know this is -6, okay? And this is a filled in dot, so my interval is going to be -6 with a square bracket. And now I have to figure out what is my highest value. And I see that this is the largest x value, so it's furthest to the right on my x-axis. Again, when you're thinking domain for x-axis, think furthest to the left and value furthest to the right. In this case, it is +3. But notice that dot is not filled in. So it does not actually include +3, just up to +3. So the line includes like 2.99999, but not quite 3. But we are still going to have that in our interval, so +3, but we're going to have a curved bracket now. Now, what does this mean if I want to put this into words? The domain includes all real numbers between -6 and +3, including -6, but not including +3. I threw in the word all real numbers. All real numbers are just any number that can fit onto a line on a graph. So there is a second way of writing this. We've done interval notation, but there's also something called set notation. It's very similar, it's just a little bit longer. So set notation, so you start with curly brackets. Since I'm dealing with domain and that deals with the x-axis, I have to write the letter x, and I'm just going to put a vertical line, almost like a border. Now I'm going to say what section do those values make up on the graph, and I know it's between -6 and +3, but does not include +3. So from -6 to +3. So hopefully you've seen these alligator symbols before. What this says is x is between -6 and +3. But since there's that half equal sign there, we're saying it could be equal to -6. Since that's missing here, we could not be equal to +3, and that's why we're missing a value there. And then I just need to write one more thing, and that is x belongs to all real numbers, and then I'm going to close my curly bracket. So that is just another way of writing it. I know it looks a lot longer, but it's just something we have to become comfortable with. So that was the x-axis for domain. If we're dealing with the y-axis up and down, we call that the range. And that kind of makes sense. We want to know what range the y values are going to be. So again, what you have to do is you kind of have to ignore the x-axis, and I want you just looking up and down. We got to start with what our lowest y value is. So we want to go as low as possible, and we see it goes down to the -4 but does not include the dot. So -4, and it goes all the way up to +5, including that dot. So if we want to write that in interval notation, the lowest value is the most bottom one. So again, with the domain, we're always looking at the left, but for range, we always have to look downwards, which is the lowest. It doesn't include that value, so I start with a curved bracket. The value is -4, and the range goes from -4 to +5, and since it includes +5 as a dot, we close it with a square bracket. So that is the interval notation. Now, how do we do set notation? Again, it's just a little bit longer, but it's not really that different. We're going to start with our curly bracket. We're dealing with the y-axis, so we write the letter y. We have a vertical line just kind of breaking it apart. And then now we got to say what range the y values are in. It's from -4 to +5. So from -4 to +5. And again, this is saying y is in between, we start with the lowest, -4 to +5. There's the half equal sign here because y could be equal to 5 because there's a filled in dot. And then we know y could be all real numbers, so y belongs to all real numbers. And we close our curly bracket. And that is the set notation. Here's another graph, but we can also figure out what the domain and range is. We just want to know from the lowest to the highest for the x values and the lowest to the highest for the y values. So again, I'm going to start with domain. Notice this is not a straight line, this is a circle, but we can still do it. So with domain, we're dealing with the x values, so we're looking at just at the x-axis. We want to know what's the lowest value, what's the highest value. So we start with the value most to the left, and I see right here, so this is -1. And it is going to go all the way to +7. And even though we don't have dots here, because it's a circle that goes directly onto the line, we can treat it like it's a dot there. So if I want to do interval notation, since we're treating it like it's right on the line, like it's a dot, we are going to have a square bracket. So we're starting at +1. That's our lowest value for x, comma, our highest value, and since it's on the line, we're closing it like it's a dot with a square bracket. So that is the interval notation. We also want to show the longer set notation just so we get comfortable. We're going to start with our curly brackets. I'm dealing with the x-axis domain, so I'm writing an x. My vertical line just to break things up. Now I have to tell where does x fall into. X is going to fall into between and including 1 and positive 7. So in this case, you will notice I have those equal signs because x could be equal to 1 because it's right on the line, or it could also be equal to 7. And I'm just going to say x belongs to all real numbers and close my curly bracket. So how would we say this in words? We would say for domain 1 and 7 inclusive. So sometimes you can just say the word inclusive at the end, and that says, okay, even though they're between 1 and 7, they also include 1 and 7. It's just a little bit quicker than saying the values of x are between and including 1 and between and including 7. So that is domain, but again, we can also do range, which are the y values. So now again, we have to ignore the x-axis. We just got to look at the y-axis for range. So you're going to deal with the lowest number to the highest number. So I got to think, okay, what's the lowest y value that this circle goes down to on my graph? And I can see it's right on the line, just like it's a solid dot at -3. And the highest value is right here, which corresponds with positive 3. Again, this circle goes right on that value, so we treat it as if it is a filled in dot. My interval notation, it's a square bracket because it's right on that value. It includes that value. The lowest y value is -3, we said, comma, and the highest value is positive 3. And it's also on the line, so I close that square bracket. Again, this is my range. All my y values are within the range of -3 to positive 3. Now we can also do the set notation. Curly bracket, I'm dealing with y values, so I put the letter y. That vertical line just kind of breaks things up a little bit. And now I got to say, what does y fall in between? Y is between -3 and positive 3, so I write it like this. Again, what this is saying is y is greater than or equal to -3, and it's less than or equal to positive 3. So it falls in between those. So this is my suggestion. Always write it so the smallest value is to the left and the biggest one is to the right. And then comma, y belongs to all real numbers. And I end my square bracket there. Now, how would I say this in words? I would say the values for y are all real numbers between and including -3 and positive 3. Or you could say between -3 and positive 3 inclusive. So here we have our third number line example. So this is a previous example, and we said that the interval notation is between -2 and positive 10 inclusive. I also wanted to show you what the set notation looks like because it's a little bit different. So in this case, instead of having a graph, we just have a number line. So we can use the variable n. And then we have our vertical line. Again, we're starting with curly brackets. And we're saying n is between and including -2 and positive 10. So again, n is greater than or equal to -2, but it's less than or equal to positive 10. But where things change is before we would say x or y are all real numbers, and we would put an r for real numbers. But if you notice in this number line, we just have a bunch of dots. We don't have a straight line like in some of the other examples. So we don't actually include all the real numbers. What we have are specific integers. So in this case, instead of n belongs to all real numbers, we can say n belongs to integers. And we close our curly brackets. And how we could say this is the values for n are integers between -2 and positive 10 inclusive. There's also another way to show domain and range. In this case, I'm not going to use a graph that has points or lines on it. I'm going to use an example of a table of values, but it's really no different. And the way we can show this is by writing a list. A list is just when you write out every single value in either the domain or the range. So here we have a table of values for our x and y values. Again, x, horizontal axis, y is the vertical axis, no different than a graph. Our domain is going to be the x values. So if I want to write a list of all the x values, I'm going to have my curly brackets. And then I'm just going to list every single one from the smallest value to the largest. So the smallest is 1, then 2, 3, 4, and 5. And I have commas in between. And I'm going to close it with a curly bracket. So that is a list. It's not the same as interval notation or set notation. It is just another option of showing you what the values are in the domain. Now the range, again, deals with the y values. I'm going to list out the range. So I start with my curly brackets. I'm going to start with my lowest value, -6, -4, -2, 0, and 2, and I'm going to end it with my curly brackets. So you're not necessarily starting off with what's first in the chart. You're starting off with the lowest values first. So in this case, again, we used a table of values, but it just as easily could have been a graph with a bunch of points, and we had to pull those values off and just write them all in a list. Sometimes it's a little easier doing it from a table of values first, though.